Hi, my name is Grace Wilmarth, and today I'm lecturing on Chapter 6.1, which is the standard normal distribution. In this section, we're going to do the standard normal distribution, which is a specific normal distribution. Hopefully, by the end of this, you'll learn how to find areas and probabilities corresponding to various regions under the graph of the standard normal distribution, along with z-scores that correspond to areas under the graph. The standard normal distribution has three properties. The first is that the curve is bell-shaped and symmetric. The second being that the mean always equals 0. And the third, that the standard deviation always equals 1. First, we're going to begin with uniform distribution so that we can see that the following, which are two very important properties. The first is that the area under the graph, which would be this area here inside, is always equal to 1. And the second is that because there's a correspondence between area and probability, probabilities can be found by identifying the corresponding areas in the graph using this formula right here for area, which is height times width. So normal distribution has a distribution with a graph that can be explained typically by an equation. A continuous random variable has a uniform distribution if the values are equally spread over a range of possible values. And a density curve is a graph of any conscious probability distribution. Not conscious, continuous probability distribution. So because the total area under a graph here equals 1, there's a correspondence between area and probability. So we're going to take this example right here. So our question was to find the probability that a randomly selected passenger has a waiting time of at least 2 minutes. So the shaded area here represents waiting time of at least 2 minutes. Since there's a correspondence between area and probability, we can easily find the desired probability by using area as follows. So you have P, which is your probability, wait time of 2 minutes equals your equation, which is height times width. So you get 0.2, which we were given here. And if you go 1, 2, 3, you're going to get 3. So your area in here is 0.6. And you would interpret this equation as the probability of randomly selecting a passenger with a waiting time of at least 2 minutes is 0.6. The density curve of the uniform distribution is a horizontal straight line, as you see here. So we can find the area of any rectangular region by applying this formula, which is height times width. Because a density curve of a normal distribution has a more complicated bell shape, it's a little bit more difficult to find area. However, the basic principle is the same. Correspondence between area and probability. There are 4 properties for a standard normal distribution. The first is that the curve is bell-shaped, the mean equals 0, the standard deviation equals 1, and the area under the curve equals 1 as well. Which you can see here, I've drawn out the graph. This is our z-score, here's that, and underneath our curve, the area equals 1, which is basically this big blank white spot. The definition of a z-score is that the distance along a horizontal scale of standard normal distribution, and the definition of area is region under the curve. So to find area for different regions, we can use technology, which would be our calculators, or we can use table A-2. But because tech is a little more reliable and our answers are more on the dot, I recommend using a calculator instead of A2. If you're going to use it, however, there are some things to note. The first and most important is that it's only designed for standard normal distribution and not a uniform distribution. And the second is to not mix up z-score and areas on the page and watch out for any kind of confusion that you could come under. And now I'm going to teach you guys how to find it. So as I said, I'm going to most likely use our calculators, but I will show both. So our basic calculators, I use the TI-84. So for finding an area between 2 z-scores, you're going to use second, which is right there. You'll go down to vars, and you will go over to normal CDF. So second, vars, scroll down to 1, normal CDF. And here you'll put in your lower and upper z-scores, and you will enter, you'll keep 0 for mean and 1 for standard deviation. To find z-score from an unknown area, we're just going to draw the bell-shaped curve and identify the region underneath the curve that corresponds to whatever equation and whatever probability we're given in that equation. You can also use technology or table A2 to find this. And to find our z-score, so not the area between two z-scores, but like just to find z-score, it's pretty easy. You're going to go second, again, vars, and this time you're going to scroll down to inverse norm. And here you'll be able to enter your area, and once again, you'll keep it 0 for mean and 1 for standard deviation. But our for our tail, you'll select whatever area is located. So I'm going to explain all of that in these upcoming examples that I have written out. So for our table A2, it's important to note that it is cumulative and it's from the left. So it's typically from a left tail, which I'm going to explain. So in this example, we have finding P, which is probability of reading, which is less than 1.23. So I recommend for every equation you draw out the bell-shaped curve. I recommend that that's what you do because it is just easier to see in general. So I drew it out. We have our mean equals 0, standard deviation equals 1, and it's less than 1.23. So we're trying to find any of our area that goes from 1.23 all the way down. So I have it shaded in here, and this is our area. So if we go to our table A-2, I kind of wrote it out a little different. I just didn't want to put up the whole thing because it's kind of confusing, but we see our z-score. So 1.23 is what we're looking for. We see 1.2, and we're going to go all the way over to 0.03. These intersect right here, and what intersects is 0.8907. So our z-score is 1.23, and our area, which is our shaded region, is 0.907. And that's essentially how you would use the A-2 table, or as I explained, our more reliable source would be our calculator. So you're going to go back up and you're going to use our calculator command. And for this one, we are using normal CDF. So you're going to once again go second, var, scroll down 1, normal CDF. So here I have it written out as that -9 6 times, but mine automatically inputs this. But if yours doesn't, that's fine. Same thing. It's basically just negative infinity is what we're putting in. And then this is our upper, so it's 1.23, just like that. Our mean is 0, standard deviation is 1. If you click enter again, you're going to get 0.89065, round that up to our answer here, 0.8907. And yeah, and yep, pretty easy. If we wanted to find our z-score, so this is that third equation that we have here, or not equation, sorry, calculator command we have here. We're going to go, so our example is all we have is just find the shaded area, essentially. So, or find the non-shaded area, sorry. So our shaded area is 0.9599. So for this one, to find the z-score, we're going to once again do second vars, and we're going to scroll down to 3, which is inverse norm, and we're going to enter our area, which is what you're given, 0.9599. Once again, mean is 0, standard deviation is 1. However, now we have tails, so you're probably confused, but if you notice here, everything to the left of what was given to us is what we're trying to find, so that's exactly what it is. So our tail is going to be left. We're going to click paste, and then we're going to click enter, and we're going to get 1.749, which we're going to round up to 1.75, and that is our z-score. And for our last example, I'm trying to find the area between two different z-scores. So our example is the probability, or our question, sorry, is find the probability that z lies between 0.7 and 1.98. So we have P, which is probability, and this is our probability equation. It's kind of written out. We're going to take our lower right here, 0.7 is less than z, which is less than our upper, which is 1.98. And we're using this equation up here. So we're going to use, once again, our calculator command, second vars, norm CDF. So once again, you're going to go second vars, scroll down 1, norm CDF. So you've got your, but now because up here we had, we were just given, sorry, 0.9599, or sorry, I messed that up. Just because we were given 1.23, we entered this, right? But now we're given 2. We're given 2 numbers. So we have a lower and an upper that we can enter that's specific for this equation. So 0.7 is going to be my lower. My upper is going to be 1.98. Once again, 0 for mean, 1 for standard deviation, paste. And then down here, you're obviously going to hit your enter button. And you've got your answer, 0.2181. And yeah, that essentially wraps up standard normal distributions. I hope you guys learned something, and yeah, thanks for listening.